Okay, just a reminder, I am not here tomorrow. So I'm going to, at my break, which is next, I'll record tomorrow's lesson online, and I'll post it online. So there will be 2 videos online. There will be this one and the new one. You guys will watch the new one. So tonight you kind of have 2 homeworks.
Wait, will we watch it tomorrow?
Not in class.
Oh, not in class.
Yeah. It's got to be done for class because I don't want everyone going to the computer lab or bringing out their computers and doing stuff.
Are we doing we do both homework things then?
Yes. So you're going to do tonight's homework.
Don't worry, Evan, it's manageable.
And you're going to watch the video and take the notes because you do have the notes now for the next lesson.
Just don't do that. You don't have to do
The homework itself is really short. It goes pretty quick. It is just area, basically. It's area being added over and over and over. So the homework goes pretty quick. So tonight, your homework is complete this homework, watch the video, do the lesson, bring it tomorrow, and do the weekend's homework tomorrow in class. Okay? That one is a longer assignment, so it probably works out better for you that you'll have the whole class to work on the homework. That way you don't have as much homework over the weekend because it is a longer assignment. Tonight's assignment should go pretty quick, so your homework shouldn't be that much longer, and just taking notes shouldn't be that bad of an assignment.
So we're doing the homework for tomorrow's lesson, like tonight. Or we're doing the lesson for tomorrow.
You're doing the lesson for tomorrow tonight.
And the homework for tomorrow.
Yes. So 12.2 homework will be what you're doing in class tomorrow. That sheet. Can I have that sheet?
We're doing Canvas.
This sheet right here is what you're working on in class tomorrow. If you do not watch the video, I told the sub that you just need to find something else to work on. So that means your homework over the weekend would be to watch the video and do the homework. So you'd have double homework over the weekend. Okay? So make sure you watch that video tonight. And you can watch it in class because, like I said, I'll prepare it right after this class. So right after this class, I'll prepare the video and put it online. So I'll be up here during the day. Okay? Any questions on that? Yeah.
You can adjust the schedule tomorrow, right?
What was that?
You can adjust the schedule tomorrow.
I'm going to adjust the schedule.
We haven't adjusted. Yeah, we have.
Yes, we have senior assembly tomorrow.
How much shorter is it? Quite a bit.
We'll worry about that tomorrow. Let's get through today's lesson, and then we'll worry about tomorrow. All right, today we're going to talk about surface areas. Surface areas are just basically how much paint do I need to paint something. So if I was painting a house, and I was trying to figure out how much paint I need to buy, I'd figure out how much one wall was, how much square feet another wall is, how much square feet the other wall is, and how much square feet is the other wall. So surface area is just a 2-dimensional measurement of the surface of a solid figure. In other words, it is just the area of the parts. I like to think of it that way. It's just the area of the parts. The hardest part about this is to actually get what parts we're talking about. So in this first example, we're supposed to determine the surface area of a regular pentagonal prism, or pentagonal, depending on who you are. So we either have a pentagonal or a pentagonal prism. So that's the way to pronounce it. They both are, except for ways to pronounce it. So we have this prism here. And we just have to come up with what shapes make it up. And so we have something here. It's called the net drawing. That's called a net. It's basically a 2-dimensional representation of all the pieces that make up this prism. So this prism consists of 2 pentagons, right? We have one on top and one on bottom. And then we have all of these rectangles. Well, if I have 5 sides of a pentagon, then it must have 5 rectangles meeting up. So we draw 1, 2, 3, 4, 5. To get our surface area, I just need to come up with the area of this, the area of this, and the area of the 5 rectangles. And then just add it all together. All right, so that's all we need to do. So we have 2 pentagons and 5 rectangles. Let's do the pentagon first. So let's mark down we have 2 pentagons. So when I'm looking for 2 pentagons, I'm going to multiply 2 times, and I guess I'll put pentagons, and we're talking about the area. So to calculate this, I just need to do 2 times the area of a pentagon. 2 times the area of a pentagon. Now let's go over area of a polynomial again. Not a polynomial, I'm in pre-calc mode. A polygon. The area of a polygon is going to be 1/2 our apothem times our perimeter. Well, in this case, we'll have 2 times 1/2. Remember, this 2 is just for 2 pentagons. That's why we have a 2 out front. This is our area. So I have 2 times the area of a pentagon. We'll half our apothem. Our apothem is that one goes from the center to the side. So that's going to be 16. And our perimeter would be, our apothem is 11. It's 11. Well, the side is 16, and I have 5 sides. So our perimeter is going to be, maybe I'll just do that up here. So our perimeter is just 16 times 5, which is 50 plus 30, so that's going to be 80. Well, the 2 and the 1/2 cancel each other out, so I really just have 11 times 80, which is going to equal 880. So 880 is the area of both of my pentagons. I have both pentagons taken care of. That's 2 pentagons equals 880. Now I have 1, 2, 3, 4, 5 rectangles. Let's account for all 5 rectangles. So 5 rectangles. And we're talking about area. And so I'm going to have 5 times the area of just 1 pentagon. Well, we have a height of 23, and the base is 16. So each rectangle has a height of 23 and a base of 16. So it's just 5 times our length times width, which would just be 16 times 23. Which is going to come out to 1840. Now, our surface area is going to be all of that added together. Is going to equal 880 plus 1840, which equals, do you have it, Evan? Or do you have a question?
I have it.
Okay, what is it?
2720.
Yep, 2720. I'm going to shift this over just a little bit because I should put, because we're talking about area, and we did say, did I say centimeters? Yes, I did. So we should put centimeters squared is going to be our final answer. So once again, surface area is just come up with what parts you have, find the area of all those parts, add them all together, and you now have your surface area. All right, a little more difficult with cylinders. Not the top and bottom. We have 2 circles, right? And the area of a circle is just pi r squared, so I can get my top and my bottom, no problem. The part that gets a little more tricky is this. So if you picture a sheet of paper, right, and you roll it up, that's all we have here, right? This is just a rectangle rolled up. So the net of this is going to look something like this. We have a circle. We have a rectangle that wraps around. And we kind of have another circle on the bottom. Yeah. We do have to find the circumference of the circle. Why would I find the circumference of the circle? I'm going to look at the circle's a little bigger. I don't like this side. What would the circumference help me with? No, I was asking you. Yeah, yeah.
Well, it would help us find like the area, the length.
It would absolutely be the length.
Yeah.
That would absolutely be the length.
One piece.
Because these circles, we just need to know the radius for, because then you see pi r squared, right? But to get the area of a rectangle, I need to know the height. Well, the height is 15. And the length of this rectangle is just going to be, like Evan said, it's going to be our circumference, which is just 2 pi, whatever our radius is. Our radius just happens to be 6. So that right there is our circumference of our circle. So that distance is how far it would wrap around this circle. That's why this rectangle is always going to be our circumference, and will always be given our height. Area of a circle is not too hard, so let's go ahead and do that. Let's just say we have 2 circles I have to add together. So we have 2 circles. We're talking about the areas of them. So I have 2 times the area of a circle. So 2 times the area of a circle is pi r squared. In this case, our r is 6, so it's pi times 6 squared. Well, that's 36 times 2, so that's 72 pi. That takes care of both my circles. We only have one rectangle. We're talking about area. So it's 1 times whatever we have, so I don't even need the 1. But a rectangle is going to be base times height, length times width, however you want to look at it. So it'd be 15 times, and we have 2 pi 6. 2 times pi times 6. Yes?
Can you just say that it's 12 pi?
You could just say it's 12 pi. I'm just putting it in there just because that's how we had it. But in your notes, you can absolutely do 12 pi. I just want to show where it kind of came from. All right, so that's 12 pi times 15. So we'd have 180 pi. So that would mean our surface area, which I'm just going to call SA, so I don't write the whole thing again, is going to be 72 pi plus 180 pi. So 72 pi plus 180 pi is going to equal 252 pi centimeters squared. All right, so the hard part about a cylinder is just remembering that the length of your rectangle is the circumference of your circle. That's the hard thing to remember about that one. Otherwise, it's pretty easy. All right, let us go to cone mode. Cone mode. Well, a cone is made up of a circle on the bottom, and then we have that cone shape. We have that cone shape, which doesn't come out to like a nice figure. In fact, all we're going to do to draw this is a circle. And our cone has to be a piece of paper that just kind of looks like that. You would wrap it up and it'd make that cone shape. Well, we have a circle, that's pi r squared. So that circle, that's pretty easy. That's just pi r squared. But the actual cone portion of it, is just a formula we're going to have to remember. The area of that cone is pi r L. It's pi r L. Where r is our radius. That's pretty easy, so that 9 would go there. And the length, it's not the height. The height wouldn't get you there. This is our height. Length means this diagonal length here or this length here. All right, so that 24 is going to be that L. So if you had the drawing, it would look like that. 24 would be on the side. All right, so that means we have an area of a circle and an area of our cone. So let's do the circle. We have one circle, which is pi r squared. So that's pi times our radius is 9. So it's pi times 9 squared, which equals 81 pi. The actual cone portion of it is going to be pi rl, which would be pi times our radius is 9. Our length is 24. So we just have 9 times 24, which equals 216 pi. So our surface area is going to equal 81 pi plus 216 pi equals 297 pi. And I don't think I did have centimeters, so it should be centimeters squared since I did have units. Honestly, this is probably the hard one. You just got to remember pi-RL. Kind of like, do they still have TRL in MTV? No? I don't know. It used to be a famous show on MTV a long time ago. TRL with Carson Daly. Anywho, the last thing we're going to talk about in class is pyramids. Pyramids. So pyramids are going to be made up of a bunch of triangles in some kind of shape. This one has a hexagon as its base. So all pyramids are going to be a bunch of triangles and then whatever shape is on the bottom. Well, this one happens to be a hexagon. So I need to get the area of the 1, 2, 3, 4, 5, 6 triangles, and then I need to get the area of the hexagon that's in the middle. Yeah?
Can we say that like all like the
all of them are the same. Yep, this is a regular hexagon.
so like all like the measures, all like the outside of the hexagons are all 26, right?
Yeah,
Okay.
because it's a regular hexagon. 26 will be the measure of each thing of our hexagon, and 43 will be the height of all of our triangles. Everything will be the same. That's what regular means. It means everything is the exact same. Well, let's first talk about the hexagon really quick. Because in order to get the area of a hexagon, I need to know the apothem, and I need to know the perimeter of it. So we need to first find our apothem. So our apothem is that length there. In order to find that length, we are going to make a triangle. And in order for this to work, we need to have a 60, 30, 90, or a 45, 45, 45. So the first thing we need to do is we need to get this angle here. I want to get the degree measure of that angle. Maybe I should write this a little bigger. I'll make that a little bigger. That should be bigger. Pew, 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 pew. All right, so I'm trying to get this measure. I'm trying to get the apothem. Trying to get that measure. And what I did is I'm going to draw a triangle to get it. I'm going to draw a triangle like this to get it. And I'm also going to say that each of these little triangles I just drew are 13 and 13 because the total is 16. Now, if I could just get the measure. I already know one's 90. I know this one's 90.
26. Right? Isn't it 26?
Yeah, it's 26.
So they're half each.
They're half each. Okay, so I need to get the measure of this angle right here. How do I get the measure of that angle? Yeah.
Oh, wait. Never mind. I was going to use like this sign.
Don't use the sign thing. Actually,
there's a triangle. It's like an isosceles triangle.
we do know it's a isosceles triangle. I just need that measure right there. I need that measure. Jacob.
Can you draw a circle around it?
I could draw a circle around it.
You can find the arc, like divide the.
We don't have to go that far. Amber?
Isn't there a formula where you do the sides to find each one? It's something with 360 and then divided by the amount of sides.
Yeah.
Oh,
Yeah. Because there's 360 degrees around here. Divided by each of these is going to be 1/6 of that 360. So it's just 360 divided by 6. So we're going to do 360 divided by 6 equals 60 degrees. So that angle right there is 60 degrees. So when I pull out just this little triangle here, I'm just going to pull out half of it. Pull half it out. I'll try to use the same colors so we can kind of see what we're doing here. We have a blue, bleu. I have 13. Well, if the whole angle is 60, that would make this one 30 degrees. This one 60 degrees. I need the apothem. I need the length of the apothem. So 30 degrees gives me my S, which is 13. So my apothem is going to be s square root of 3. In other words, 13 square root of 3 is my apothem. Yeah.
Did you even need to like do that 360 divided by 6? Because like when you split in the middle, when you have your 90 degree, don't you just know that like what goes opposite of that is going to be that 2s, so that...
What if this was a 45-45 degree triangle? What if it wasn't a 30-60? What if it was actually, I don't know. We don't know for a fact. We have to prove that it's a 30-60 before we can do that. Because if this wasn't a 30-60, then we'd have to use sine, cosine, something else to get that angle. So as long as you assume I put this on the test as is, then you can assume that, but assuming is probably not a great way.
You can't assume anything, though.
Right. That could create disasters. All right. So that is going to be 13 square root of 3 is my apothem. So let's take care of our 5 triangles, then we'll take care of our pentagon, and then we'll be adding and be done. So we have 6 triangles. Remember, we're looking for the area of all 6 of them. So that is going to be 6. Are you missing one? Oh. All right, so it's going to be 6 times the area of one of the triangles. One of the triangles is half our base times our height. Well, our base is 26, and the height we said was 43 because it's running right up along there. So this is times 43, which would be 3 times 26 times 43. What'd you come up with, Evan?
3354.
That's what I got too. I'm actually going to put it underneath. So that's going to equal 3354, or 3,354. That is the area of all the triangles. Now we just have one hexagon to deal with. We have one hexagon to take care of. We know the apothem. We just need the perimeter. So that's going to equal 1 times our 1/2. I'm going to write it again. Apothem times our perimeter, because we haven't done this for a while, so why not write it down again? Well, perimeter is just the base times how many you have. That would be 26 times, we have 6 sides, so our perimeter to be 26 times 6. So this is going to equal 1/2. We said our apothem was 13 square root of 3. 26 times 6 would be 156. Now what I would do 1/2 times 13 times 156, because that square root of 3 must stay there. Did anyone come up with that? Akshay?
1014 radical 3.
Does that sound right? All right. Now we just add those 2 things together to get my surface area. I guess I kind of ran out of room here, so let's try to not write too big. So surface area is going to equal that 3,354 plus 1014 square root of 3. There's no way to push those together as is. I look for centimeters. There are centimeters, so I'm going to put this in parentheses. Centimeters squared would be our end answer. That would be the end answer. We don't have to go any further because we can't put those together. Questions on that one? All right, then all we have left are just some drawings of nets that can kind of help you out. And I'm going to put some information on them. So if we have a prism, you're going to have 2 polynomials on either side and a bunch of squares. Just remember the squares or the rectangles are just length times width. So these are all length times width. And the area of our polygon is going to be half our apothem times our perimeter. So that way you just have the formula right there. If I have a pyramid, we have a bunch of triangles. Remember, with triangles, your height would be there. That would be your height. And so the area of a triangle is half your base times your height. Well, the rectangle or the square in here would just be length times width. For a cylinder, you'd have 2 pi RLs, or 2 pi r squareds. And then you'd have a length times width in the middle. And the one we just got to kind of remember, the cone portion of this would be pi RL. but the circle is still pi r squared. All right, any questions on what we covered today? So the homework is not that long. It's just a lot of just making sure you get the net correct of what you're calculating. The hardest problem is just, I think the last one is a barn problem. That one can be a little infuriating because there's a whole bunch of shapes in there that we kind of have to look up how to get the area of, because there is, I'll let you just find it when it happens. There's a shape we didn't cover. Hint, hint, trapezoid.
What?
A trapezoid.
That's not fair.
Yeah.
Okay. I
Life
think I
isn't
remember
fair.
what that is.
You don't remember what a trapezoid is?
I think so.
Okay.
It's a parallel-sided
Yeah.
figure
I
with
don't
4 sides that are
It's
not
something,
parallel
that's what it
things.
is.
Okay,
But a trapezoid's area, if you want to remember, is just half the height times base 1 plus base 2. Yes, Sabrina.
So question about the rectangles. So what if there are two rectangles involved, but they're two different kinds of, like, so.
So then you have to, so if you happen to look at, number 3 actually has 3 different rectangles in it. Number 3 has 3 different rectangles. It has the one that's on the face, which is 6 times 7. You have one that's kind of flat, which is going to be 10 times 6. And then you have the one that's in the back, which would be like the hypotenuse of the triangle. That one would be a different length. All right, so that one has 3 different types. So you just have to calculate each rectangle. 7 has multiple different sizes. Nope, they're all the same. Scratch that. But 3 definitely has different size rectangles. 2 has different size rectangles. A lot of them have different size rectangles. Just add them all together, okay, Sabrina? Yep. Other questions? All right, you do have time to work.